So Jesse, we're here.
Fantastic.
Okay, so let me just introduce our guest here, Jesse Aust from Retrocausal. Retrocausal is a startup company, I believe. In fact, almost everything these days related to AI is a startup company. But I think Jesse, you reached out to us maybe initially. That's how we first got connected.
Yeah, we were interested in having a couple of team members come to the mixed model line design over at the Toyota facility.
Right. And so you were able to attend. That was back in February.
Yep.
And that started our relationship. You met Gerard in person, and we'd been dabbling with AI since it became available to us, which I guess was last year sometime. And so we're very interested in the topic, and we thought it would be a great opportunity to spend some time with you, and hear more about Retrocausal and your current efforts, your current products, and then where we see things going in the future with this, because this world of AI is changing so quickly. In fact, I was never nervous until last week when I started using ChatGPT 4.0 on my phone, where I was actually starting to have conversations, with audio conversations, which I hadn't had before. And it actually started making me a little nervous, just engaging at that level. So the basic format that we want to follow here is kind of past, present, and future. Of Retrocausal and where you see things going, maybe with a heavier emphasis on present and future. But for starters, Jesse, could you just share with us some of the history of Retrocausal and how it got started, and what the roots are of your particular company?
Yeah, definitely. And just to make sure I get a chance to say thanks for having me on. I know we've talked about this for a while, so I'm glad we finally were able to do it. It's been a pleasure getting to know you and Gerard further after our initial meeting in February, so I appreciate it. In Retrocausal, it's very common to refer to a lot of the startups in AI as startups, but several of us have been around now for quite some time. Ourselves actually since 2018, and I believe we're just under 20 million in total funding at this point. So we're graduated a little bit beyond that startup phase.
Oh, okay, good.
Maturity of our products are definitely obviously enterprise grade, because that's who we work with, some of the largest manufacturers on the planet. But we did come from, I guess you would call it, humble beginnings. Our founders they were actually part of Microsoft's HoloLens team originally, the AR goggles that were primarily developed as hands-free AI-powered computers for frontline workers, right? And so Zeeshan Zia and Andre Cronin, they actually were early enterprise design partners for HoloLens. So, they were the core founding engineering team behind that technology. And, through that, they realized that there was a need for human-centric AI that didn't require, frontline operators to put on uncomfortable goggles, essentially, right? We could remove that component and still provide that core capability. And Zeeshan also had supervised AI PhD students on zero-code programming of systems that could follow, really complex manual operations, and, saw that there's a market pull for that capability. So that's what led him and Andre to spin off and start their own company. And they did that in 2018. I don't know if you remember back then, there was a push for the HoloLens product, and the market fit and demand really, I don't think it was quite where they wanted it to be. And so it almost seemed like they put that on the shelf. And that's when Andre and Zeeshan moved across the street from the Microsoft campus in Redmond and opened up our first lab and founded Retrocausal.
Okay. Oh, there we go.
There's Gerard.
Yes.
Welcome.
And of course, in time for me to change into a comfortable T-shirt. So here we are.
Yeah,
I thought I was out.
It must have been the shirt that was causing the problem.
Yeah,
That's probably what it was. Sorry about that, folks. I was following in the other mode, so please continue.
Yeah, definitely. So yeah, we're just finishing up kind of how we got started, and I guess we can talk about some of the early challenges that we had as a company moving forward. What led us to kind of our first milestone. We came from Microsoft, right? It's a very horizontal product culture, and initially built technology that could target multiple verticals. We at Retrocausal, we initiated pilots with a vast array of different sectors and market segments, medical training, construction, distribution centers, manufacturing, and retail. And when we were building our go-to-market playbook, originally we had done it for multiple verticals. And, when we set out to do this, we wanted to build the best product for the best fit. And, quite frankly, you can't do that you can't spread yourself too thin as a startup, right? Because you're resource poor when you're starting out. And so we decided to focus on one vertical, and we picked manufacturing because that's where we saw that the pain that manufacturers were experiencing was the most intense. And that's where we thought that we could deliver the highest ROI for our customers. And when we did that, we immediately saw traction. So we figured that, and now we know that we picked the right direction the first time.
One of our clients from a long time ago used to refer to certain. He would say that where to start. Wherever we can get the best ROI financially, or the one that can improve the misery index. He said. Right. Yep. And of course, we're going to get a little deeper into this with your product. But as far as I'm concerned, for what I understand about your product, it really helps with the misery index.
Yep. Right.
Having to stand for hours on end on your feet with a stopwatch, observing 12 repetitions of the same task. Eliminating that, to me, that is just a godsend.
I mean, the misery for the industrial engineers, right?
Oh yeah. Well, I'm an industrial engineer by
you are
training, so you made my career a little too late for me, but hey, for the younger guys, absolutely.
Yeah. Better late than never.
Yeah, absolutely.
So yeah, essentially we build products to solve, mission critical challenges, the biggest challenges that face manufacturers today. And we got our start really where we kind of hit our first milestone and started getting the right type of traction is, the Techstars Accelerator in 2020, which I don't know if anybody on the cast is familiar with Techstars, but it is a program that selects the top emerging technologies in the Pacific Northwest, and essentially, puts these companies through an incubator, and it's got under a 1% acceptance rate, so they really go through with a fine comb and to bring in the best of the best. And it was really pivotal for us, helping us connect with the venture capital community, getting some more market visibility. And we actually raised our seed financing in 2020 through a non-dilutive grant from NASA's Jet Propulsion Labs. And quite frankly, they needed someone to essentially would build a program that would guide their Mars mission astronauts through medical procedures and maintenance operations, critical procedures and tasks in flight. And so that's, again, that was kind of our first real milestone as a company. And we've really been on a fast track since then.
It was probably helpful to be working with them in 2020, which was not a great year for for a lot of other companies.
Yeah, definitely. That was an interesting time. We actually had built a couple of programs, so we're a very adaptive and agile engineering and development organization, and that is one example where we could pivot quickly, and we provided programs for companies that we viewed the manufacturing floor as a whole and would be able to fire off alerts when operators got within that 6 feet distance of each other, which was a custom tailored solution that was needed across the board. And so one of the things that we're very good at doing is listening to customer and market feedback and being able to hone, enhance, and refine our tools specifically to those voices.
Okay, well, we've alluded to what your products actually do, but probably most people watching this don't know yet.
Yeah,
so
which brings us to the present, right?
Yeah.
What are your main offerings? And to me, I want to make sure that we do talk about the Kaizen Copilot because, again, as an industrial engineer, I think that's just brilliant. So we leave you to pick the direction or the start point to talk about the present, and then we'll go into more of a Q&A mode.
Yeah, definitely. So we have two main product offerings that we bring to market. We have our Assembly Copilot and our Kaizen Copilot. And our Assembly Copilot has been, our core offering for the last 3-4 years. And the Assembly Copilot is a very specific tool, again, that's catered to solving 3 very critical challenges for manufacturing today. And those challenges, one is, quality control. And I'll back up a little bit and say, for our Assembly Copilot, we specifically focus on the manual assembly aspect of operations on the manufacturing floor. And the way the product works is we build an AI model off of a training data set that we collect of an operator performing a process correctly. We train an AI model on what that process should look like using activity recognition and object detection. And then we train that model. So when we deploy it on the line, it knows what a correct process should look like. So through the computer vision technology and capability, if an operator misses a step, performs something out of sequence, it can provide immediate feedback in real time so that they can fix that mistake or be aware of that right then and there. And so they can fix that on the fly prior to inspection. And we can essentially mitigate within the first 6 months of deploying, we can reduce the amount of manual assembly related errors by about 60%. And within 12 months, we're at about 80 to 85%. So that quality control is really comes from upskilling those operators on the front line and providing them with some augmentation, technology augmentation that really just allows them to do their job better. So the quality control is kind of the first area that we attack. The second is process improvement and continuous improvement activities. And we do that through providing the industrial engineers and the engineering team and CI managers with prescriptive analytics. So while we're watching the operator, while we're facilitating that quality control process, we're also aggregating all of the data that occurs within that cycle. So we're collecting the overall cycle time, individual step times, sub-step times. We're tracking areas where operators are making mistakes. We can do productivity comparisons between stations, between shifts. And so we put all of that data into a really easily ingestible format and provide it to the engineers in real time. So historically, you've had to wait till after the fact to get that data, or you've had to go in, like you were talking about previously, Gerard, and manually aggregate that data as a team. But now we provide it to you in real time, which is why we refer to it as prescriptive analytics, because you can actually use that data to identify bottlenecks as they occur versus identifying it after it occurs and it's already become an issue in the line.
May I ask a question there?
You may.
Because, Richard, you and I have done this a million times. Look for a high point of view, look at the line, and watch people walking to retrieve parts and say, see, right there, waste. What we need to do to solve this is one person identifying one issue. And then I keep looking and I see that someone is performing a task in an ergonomic manner, right? Instead of turning a torque wrench this way, he's turning it this way. And that's bad for the shoulder. One guy, one issue identified. And the best I can probably do is identify, 10 in a day, one entire person, right? One engineer observing for hours and hours and hours, identifying just a few things. Are you saying that the assembly copilot can gather all that data from a specific workstation, I gather, and say, hey, look at everything, look at all these things I saw, and give you a list of all those potential improvements?
So that's actually on the roadmap is when we're tying in the back ends, both our Assembly Copilot and Kaizen Copilot. And I'll talk about that in depth because it really broadens the capabilities of both tools. For right now, we're just aggregating the data and then we're batching. So we also have traceability in that data as well. So we're not only collecting the data, but we're storing the video data along with that data. So you have traceability, and we're batching the videos of those cycles under a good and bad label. So you can actually go at any time and see, okay, what's occurring in these bad cycles, and you can see what those issues are, right? And it could be an ergonomics issue. It could be a station layout issue. It could be an inventory issue that you weren't aware of. There's a variety of things that you can see because now you have that traceability function. So rather than having to stand on the floor and observe and monitor for an extended period of time to be able to catch these, you've got it at your fingertips in real time anytime you want to take a look.
So basically, you're turbocharging the engineer here. You're giving me a lot more data, a lot more. All the time that I spent observing, now I have the assembly copilot doing the observations for me, giving me the data, and then I can invest all that time into active solutions.
Correct. Yeah, it's like having a trained supervisor that's at the station where it's deployed. Yeah. It's on 24 hours a day.
Okay, hey, Jesse, we have a question here from John in the chat. It says, if a company is data poor, how is your AI model built? Maybe you could expand on that a little bit.
Yeah, that's a good question, John. So we built the product from the ground up to function as a standalone, right? So natively, we don't need any outside data to be able to function. And so the system is deployed on commodity hardware. What you need for the system to run is a low-end GPU-enabled laptop or form factor, a PoE camera, and just your run-of-the-mill monitor. The data inference occurs at the edge-based device, right? So if you think of it this way, the ears, eyes, and mouth are the hardware that's on site, and the brain is what runs in the cloud and does all of the heavy lifting. So the inference and data collection occurs at the edge. That's where we get the data that we need. So we actually don't need any access to historical libraries or any databases that you have on site in order to function. And then on the flip side of that, we did build the system with an open API, so we can tap into your MESs, your PLCs, your IoT tooling, historical libraries, so we can actually perform at a higher level, right? So we can actually incorporate some of those commands that you would get from your execution systems and build that into the logic of the assembly copilot as well. So for instance, if there's a critical step, if it's missed or performed incorrectly, we can work with the PLC to stop the line, and we can add in another layer of verification to where unless that step is completed, the line won't continue. So things of that nature we can build into the logic.
Well, if the company's data poor, I think you can, through either the assembly copilot or I think the Kaizen copilot, actually gather that data, right?
Correct, yeah.
Time studies, for example.
It's the first step in getting you out of that data poor stage.
Yeah. So again, leverage, right? Is not replacing me as industrial engineer. It's just leveraging me, giving me more power.
Exactly.
Yeah. Okay.
Now,
excellent.
If a company is not data poor, let's say that they pride themselves on actually having good work instructions, step-by-step documentation. Like most aerospace companies can't do anything unless they have that, right? They can't, they can't authorize the work to start unless they have detailed step-by-step instructions. Could Assembly Copilot make some use of that information?
Yeah, definitely. So when we're in the initial phases of training an AI model, one of the aspects is annotating that data, right? Which historically has been an extremely cumbersome phase of the process where you would have to have someone manually selected to sit down and annotate each individual cycle in that training data set. You can upload your existing SOW and your SOP bill of process. You can upload that existing into the system to marry that naming convention with the activities that are performed in the video.
Hey, I have another question here from David. He would like to see a demo. We're not going to do a demo because we only have an hour, but Jesse, I'm sure you can provide a link for him to see a demo, he says, of AI auditing an operator, checking method ergonomics and cycle time. So
there's some YouTube videos for sure out there.
Yeah.
Yeah,
So
at the end of this, we'll put in a link in the chat. You guys can reach out and schedule something just through the website, and I'll put my contact information in there as well.
Perfect. So, Assembly Copilot. It to me, it is remarkable and maybe even a little hard, a little too good to be true to believe that an AI engine can identify all the different parts and tasks and tools. You tell me that through object recognition, all that is possible. It's been tested, and it works. It can recognize a wheel, a nut, a bolt, a cylinder, all that.
Yeah, so I think it's important to remember that, again, going back to kind of our origins, our pedigree is really light years ahead of where everybody else, that is coming into the space is. So, Zeeshan himself is one of the top computer vision scientists on the planet. I mean, you really can't have a conversation without referencing Zeeshan and computer vision. And not only is he one of the top computer scientists on the planet, but he also has his roots in engineering. So he actually used to design logic for PLCs and MES systems as well. So, we build the algorithms that the computer vision uses. All of this is proprietary, obviously. And so when we train a model, and I'm glad you brought that up. And after this, we can talk about the operator training because it's a good segue into that. We build a model, and your AI will function as it's been trained, right? So we train it on a correct process utilizing standard work, standard station layout, and your bill of process. And so when we deploy that, it knows exactly what components are in what bins. So if those get shifted around, it will fire off false alerts. It knows what activities need to be performed in what sequence. So if they're out of sequence, it will fire off alerts. Or you can train it to where just as long as all the activities are performed, doesn't matter what sequence. But if they miss one of those, it will fire off an alert. So we train the system rigorously to be able to identify anomalies that stray from what that SOP should look like.
So if there is a change, this bin for this bin, because it's ergonomically better, then the system will have to be retrained to recognize that change.
Yeah, retraining from that aspect is a simple process. Typically, we'll just record a couple of cycles and inject those frames in the original model.
Okay. So no big deal. Because I want to make sure, and correct me if I'm wrong, I don't want it to come across as rigid, right?
No, it's extremely malleable.
Okay.
Yeah, we built the system in a true zero code, no code process, right? So we can typically train someone to be an admin, not just a user, but an admin of the system to make those types of changes in an hour or two. And we typically do that at the end of our deployments.
Okay, so it's not like now that we adopted this technology, we need to employ 3 additional engineers just to manage the
Not
system.
at all. No, its inherent function is to be self-serve. We want to make sure that we're not the bottleneck, and so that's why we built the system to be able to function when we're hands off.
You know, it triggered again in memory, Richard and I being the old guys here, of one of our clients that decided to get deep into simulation and ended up hiring an entire department just for simulation. Mm-hmm. And it was, dozens of people doing simulation. And we're not talking about that. We're talking about with your resources, actually, you are taking away, you're returning, you're giving them back some time to be able to do improvement rather than drudgery, which is pretty awesome. So you did say 2 major offerings. We talked about the assembly copilot, and this is the day-to-day, right? This is my daily companion, helping me carry out the work with focus on manual assembly. Is that correct?
Yeah, the assembly copilot is an always-on system. When you're in production, the system is on. And when because I know we're going to segue into the Kaizen copilot, I did talk about the 3 main challenges that manufacturers face that we address. And we talked about the quality control with the digital work instruction, in-process task guidance. We talked about getting access to data for process improvement and traceability. And the third one of that, which I wanted to touch on because I know it's a key pain point for everyone right now, is the operator training, right? And so, one of the biggest challenges that I hear on a daily basis is it's just really hard for us to get people on the floor, and it's even harder for us to keep them on the floor. And so there's this constantly revolving door of operators that they are needing to invest a massive amount of resources just constantly training people. And so through our light guidance and projected digital work instruction module, we can effectively reduce the time it takes to get someone on the line by about 50%. In fact, we did a case study with one of the largest auto manufacturers on the planet. And essentially, we did a side-by-side comparison with their current process and then utilizing our training process, and took a sample set of 100 workers and with an MPI to see who could reach the objective cycle time in the shortest amount of time. And we were able to reduce the time it took to get those operators to that objective cycle time by 66% over their current system. So I know that right there from a resource standpoint, it is just a game changer, being able to redirect headcount and dollars to areas where it matters more, right? So we can take the training on our end, reduce the time and resources it takes to get people on the line. And really, we can take someone who's never seen a process and get them on the line and walk them through it. Their cycle times will be poor at the beginning, but we can just get them on the line typically in under an hour.
We have a question. Actually, I have a couple of questions here from Sharuk. I'm going to go to the second one. Sharuk, you may want to contact Jesse directly for your first one. Seems to be very specific. For the second one says, do you integrate operating procedures into the model?
That's Shakir, Gerard.
Different person. Okay. Oh, 2 different questions. My deepest apologies. So I'm going to go with Shakir's question, then we'll go back to Shakir's question. So do you integrate operating procedures into your model? And then he's assuming that there is a need for some customization of the system. I don't think the system needs to be customized, right? The customization is natural because the system is learning your work. So, and we did hear you say that you do integrate operating procedures if they do exist. Help me with that.
Yeah, no, that's a great question. So, I'm going to answer this from 2 different ways. So the first way is, in our assembly copilot, when we break down, when I was talking about how we aggregate the data that occurs during a cycle, so we break the time spent in a cycle down to your standard value add, non-value add, essential non-value add, but we also track background. So we give a TAC grade and a TAC score to each process, so you can see where the operator is spending their time during that process. So that allows you to identify waste in the procedure itself right there. But when we're going to a process, like a strict process improvement and process design standpoint, the Kaizen Copilot is really going to be your game changer when it comes to identifying waste. And I think this is probably, if you guys agree, a good segue into talking about the Kaizen Copilot and its capabilities.
Yeah, and Shabrook, if you'd be so kind, contact Jesse directly for your question, because it's really specific. So let's transition over to the Kaizen Copilot, because again, this is, to me, and then again, I understand that my understanding is limited, but again, to me, this is eliminating a lot of drudgery and providing a lot of leverage to us industrial engineers, actually to any ME or to anybody in continuous improvement. So please explain, what is the Kaizen Copilot?
Yeah, so the Kaizen Copilot, the best way to explain it essentially is you take all of your modules that are involved with a standard Kaizen event, and we built that into essentially a super app. So from a technology standpoint, we utilized our own generative AI called Lean GPT. So, and I want to make something clear up front is that, right now, it's very easy to group everything into your Chat GPT type product, right? Where, it's a prompt-based service. You put in your data, it gives you some answers back. But Chat GPT, we all know when you use it, it takes all of that messaging and all of those conversations and utilizes it to train itself. We don't cross-pollinate customer data, right? So anytime someone utilizes Kaizen Copilot, their data stays with them. Mm-hmm. We don't use it to train an overall model. We've already trained our model on every existing available source that references, Lean Six Sigma, TPS, anything related to process engineering, manufacturing engineering, continuous improvement, textbook, white paper, blog, etc. We scraped the earth, right?
Including ours, right?
Yeah, that's what we built our generative AI on. Now, the Kaizen Copilot essentially is a copilot, right? So it will do for you what you tell it to do. What we wanted to do is take what you were talking about, the drudgery, the manual aspect of Kaizen events, and we wanted to essentially automate that process of it, right? So you can spend less time on the floor collecting the data and more time working the data, so you can get to the actionables that you need from hopping in and diving into that sandbox. And so essentially, with our Kaizen Copilot, you can perform a Kaizen event really with a single video upload taken from a cell phone mounted above a workstation. And from that, there's a couple of prompts that we need from you. Again, going back to, it's a copilot. It will do what you tell it to do. From that video, once you upload it into the Kaizen Copilot, all you need to identify is a single dimension line from the workstation itself. And we have pixelated technology that will take that single line and then bring it to the overall dimensions of the workstation, and then tell it how many steps are in that video, how many steps are in that cycle. And then we will utilize the unsupervised video segmentation with our activity recognition technology and identify those steps. So it will analyze that video, and right off the bat, it will give you an initial analysis that includes all of the steps broken down, right? It will apply third legs to all of those steps based on the activity recognition. It will identify which ones were value add and non-value add. And then it will also give you, it's got an initial set of questions that we would like you to answer so it can learn the process a little bit further. It will give you ergonomic reach zone analysis. It will give you spaghetti diagrams of the operator movement, so you can see where haphazard movement is taking place, where efficiency can be improved. And then it will also give you an initial set of efficiency suggestions based on what it saw and the questions that it asked you. And these are where, we're getting into that too good to be true territory that you were talking about. This is where the core of our generative AI takes over. And you can ask it things, like how can we improve the activities in step 3, right? How can we reduce this step time by 10%? And from that prompt, it will give you back suggestions based on what it saw in the video. And along with those suggestions, it will give you cost savings analysis from those implementations. And that's based on the prompts it receives from you. It will also give you initial suggestions based on what it saw. For example, can you slide this component across the work surface rather than picking it up and placing it there? If you can, this will save you 1.5 seconds in your overall cycle time, will equate to $7,000 in savings a year in operator wages based on the national average. So, and that's just, one example. It will give you, roughly 20 to 30 suggestions based on that initial analysis. And that's just in the station design module.
And that is per station, right? So again, one video, one station, and then again, this multiplies actually is to me is more than multiplicative. For every station. Is that at the station level we're talking about?
That's at the station level. And what you can do is so let's say you've got a line that's got 10 stations. And this will take us right into our line balancing. So you can record a video for each one of those stations, right? Do the analysis. And at the end of that, in the system, you can actually stitch those together to create the line. And you can perform line balancing. And in our line balancing module, it allows you to select your line balancing based on operator count, takt time, volume that you're looking to produce in a given shift. And so that gives you that simulation where you can sandbox your line balancing to reach the optimal level of efficiency based on your required outputs.
So this. And I'll also will put it out to the audience, because based on experience, again, this is not something that I can prove scientifically, but based on experience, and as you can tell, I have a few years on me. A properly conducted Team Kaizen event is 3 weeks of data gathering, 1 week of deployment.
Correct.
So it seems to me that what you're doing here is saying maybe the 1 week of deployment needs to take place because we need to come up with ideas and do some PDCA. Even if we say that stays, it seems to me that those 3 weeks of data gathering, you're turbocharging that.
Correct.
Am I on the right track there?
No, you're exactly right. So again, going back to that initial task that we set out was to be able to automate as much of the data gathering process as we could for the industrial engineers and give that data to you in a very easily ingestible format, and also in a way that you could sandbox that data with, rather than your traditional sandboxing. Now, it's a click to play, right? So now with a couple of clicks, you can simulate hundreds of different scenarios with that data that's already been analyzed. And you brought up the PDCA because continuous improvement PDCA is one of the modules as well. And then we've got the PFMEA analysis and control plans, as well as the ergonomics assessment. And I think that's another one that we're extremely proud of, is that we probably have the most refined ergonomics suite that manufacturers have access to. EHS departments will have a heyday when they see what they have access to, because we're sensorless, right? So just with the same either a webcam or a cell phone, with no sensors, we can do a full ergonomics assessment from a Reba standpoint, a Rula standpoint. We can do NIOSH lifting, Snook tables, even down to grip and pinch scenarios. And it will give you, once you do an analysis on the ergonomics, it will show you where your operator's at risk. It will show you where your operator's at risk over time, over load, you name it. So it's, we were extremely proud to bring this to market back in February, and the feedback that we've gotten so far has been that it is, again, you use the term turbocharge. We're turbocharging the capabilities of your existing departments.
We're coming to within a stone throw of the hour, and I know we started a little later, so we may go a few minutes after. But folks, start line up your questions so Jesse can answer. But while the questions are coming, when I think of turbocharging those 3 weeks of data gathering, and then you telling me that it's not just the time studies, it's the ergonomic assessment, suggestions for improvement, PFMEA, and on and on and on. In all fairness, we can never gather that much data for a Kaizen event at a human level.
Correct.
Or we can do it in many more weeks. But this is way more than just turbocharging. This is I think this is in a completely different level. Would you agree with that, Richard? This is just another plane.
Yeah, I'm looking forward to getting my hands on it. There are some YouTube videos as well talking about Kaizen Copilot, I believe, Jesse, right? So
we actually, I'm going to put some links in the chat that everybody can reference.
Okay, that'd be great.
Yeah.
Now, I want to spend some time on future as well. I'm looking at the clock as well, so I don't want to cut ourselves short on talking about what's coming, right, in the future. Could we do that?
Yeah, definitely. I think the main thing is specifically with the growth of this specific technology sector, we still want to be and continue to be the best at what we currently do, right? And that comes from continuous improvements, upgrades, enhancements, taking feedback from our current customers, potential customers, custom feature requests. We had one the other day because in our Kaizen Copilot, we have, I think it's slated to be released next month or the month after for our PMTS mode apps. And we had an automotive customer that had a specific set of codes that were built specifically for them. And so being able to integrate those codes into that module is something that we're going to do. And so again, going back to the fact that we're extremely agile and aggressive when it comes to our engineering and development capabilities, being in a position of where we can customize and still cater to the market, again, gives us a foothold that a lot of companies don't have. And so for the future, we still plan on being the leader in the manufacturing process management category. And that's really where you can, I don't want to use the term one-stop shop, but that is essentially what we want to be, where you can do the continuous improvement, the quality planning, the health and safety planning, the manufacturing engineering analysis, all within our software. And CB Insights already included us in their inaugural Advanced Manufacturing 50 list after analyzing more than 6,000 companies. And then we're one of only 4 manufacturing technology companies in their top 100 AI companies for this year. So we're starting, to be recognized. And this is really the first year that we've done any type of actual marketing. And for us, again, going back to, we wanted to be really good at what we did. We spent the time developing the tools to get us to where we're at today. And now we're finally, I guess you would say, letting our voice be heard to the broader market. I think just being better at what we do, enhancing our computer vision language modules to where we can be a little bit more automated in what our vision system recognizes without further human intervention and command. Marrying and bridging the gap between the back ends of both our Assembly Copilot and Kaizen Copilot so they can work congruently with each other. That's also a big goal of ours We've got plans to work with cobots in the future as well, and bridging that gap between the robots that still require human intervention. And then, broadening our integration capabilities. So we have some native out-of-the-box integrations with MES systems, OPC UA, IoT tooling, smart tooling, light towers, barcode scanners, MES systems, etc. But we want to be able to speak with everybody's existing tech stack. And so that means from our end, we have to constantly develop integrations that can occur out of the box. And so we want to work with all of your smart tooling and connected tooling and torque drivers. We want to work with all of your PLCs. We want to work with all of your MES systems. We want to be able to integrate with your SAP system or your ERP system right out of the box. So that's a big, heavy lifting task for us that we're constantly in the trenches with as well. So as far as the future goes, I think that kind of covers, the basics of where we're headed and what we plan on doing.
I would guess that it's not a big leap to go from the assembly copilot capability to having a cobot or robot do those steps. I mean, it seems to me once you have that knowledge, right, that being able to integrate with a robot of some kind. I'm not necessarily suggesting that's a good idea, but it seems like that should be possible. You mentioned cobots just a second ago.
Yeah. And what I am liking a lot in what you're saying, Jesse, is we're planning to become better at what we do, manufacturing. Having been in the manufacturing space for, measured in decades now, frankly, nothing new has come to manufacturing. It's been all the same old thing and just boring as always. Well, yeah, now we used to have Mapix and BPix, now we have SAP. It's the same thing, right? Just more complex, Germanized, if you will. So in all the automation, all that stuff, yeah, it's all the same thing. Here, this is, as I said, this is on another plane. And I'm really looking forward to seeing it more and to actually learning about it. And to see applications beyond manual assembly, which brings me to a question. If you don't mind, Jesse, I have a question from Tom. How applicable is to batch chemical processes in electrically hazardous areas?
So I would need a little bit more color on that question to answer it effectively. But so we work with, some of the largest electronics manufacturers and electrical assembly manufacturers on the planet. And, one of the things that we do well is work with single piece flow rather than batch processing. And so again, Tom, I'd love to answer this question, and I'd love to hear a little bit more about this specific scenario, just to make sure I can get you an answer, because I haven't to answer it effectively.
I can see a future where Retrocausal learns to train the model where the batch is the unit of flow. And sometimes, when we teach batch manufacturing, which sometimes is necessary, right, in machining environments, the unit of flow, the single piece, is the batch because there are changeovers. I can perfectly see the Kaizen Copilot applied, for example, to the beginning of the batch process, which is a changeover, which changeover improvement could be a big deal. But then again, this is just me dreaming of you guys making my life even easier.
Yeah, no, and that's, I'm glad you brought that up, changeover, because one of the other areas that we're getting a lot of traction is the machine setup and breakdown. Because a lot of the times you've got very complex machine setup that taking place before a shift starts. And I've got manufacturers say, I have a setup process that should only take 30 to 45 minutes, but our untrained operators, sometimes it takes them an hour and a half to 2 hours to set up and break down this machine. And so that, really just going back to manual operations with activity recognition, essentially we're just training a model on what the correct activities should look like in setting up and breaking down those machines.
Which, with that, you answered Michael's question, right? That you answered that question. I have one from John. Can your AI system detect conflicting data when building the model?
Yeah. So, John, if you're still here, I would want to know what defines the conflicting data, because that's a broad set of answers I could provide. If we're looking at conflicting data, so if let's say we're uploading the training data set, right, and you want to upload correct processes, so you're training the AI model on correct processes. Well, let's say you upload an incorrect process. Yes, the system can detect the conflicting data between an incorrect process video and a correct process video. But going back to, the system will function as it's been designed. So if we've got a specific logic associated with those data sets, then we can train the system on what the conflictions are to be able to identify those when it's deployed.
Okay. Jesse, you attended a workshop back in
February, must have been.
Yeah,
February?
it was February.
February. So that was the mixed model line design workshop, which we're doing again in August. So I can see that at some point in time we will incorporate some, because right now the way we teach lesson 10, which our lesson 10 is on standardization, we talk old school, right? With nothing wrong with that. But at some point in time, I'm going to have to bring in some of the technology and say, there is this new technology that can do the time studies. And in that lesson, we talk about tasks and materials and times and categorizing the times and identifying the quality steps, all that, always from the standpoint of you observing, making these determinations and gathering this data into an Excel spreadsheet or writing it down by hand. So at some point in time, that's going to become, I don't know if the correct term is obsolete, but drudgery that nobody will want to do.
Correct.
So that we also need to come along with the technology, Richard, in the way we teach that. And maybe that doesn't happen for the next, I don't know, whatever time, 1, 2, 3, 5 years, I don't know. But at some point in time, that is why are you teaching me how to use an abacus? Look, I have a calculator kind of thing.
I mean, that raises the question of what other AI capabilities can we apply to our process, right? Our mixed model line design and mixed model material flow processes. Apart from what Jesse shared with us, I mean, there are other areas as well that we need to be thinking about. And all of this is kind of sort of overwhelming because it's happening so quickly.
Yeah.
I mean, within the last, a little more than a year. Now, of course, Jesse, Retrocausal was founded in 2018, so you guys were involved with this. But as us people on the street, we weren't really aware of what was going on necessarily until last year.
Yeah, and Richard, you and I, we are in this business, right? We are in the business. As for us, this is a tsunami of information, a tsunami of changes, and which is all great. It's all welcome. But I think that is also important for the folks at Retrocausal in the way that you introduce this to the market. Make sure that you're not making us drink from a fire hose. Actually, how do you go about implementing this, Jesse? So it doesn't feel like you're burying me with stuff that is all too new.
So, I mean, that's a great question. And, there's two really important aspects that you bring up. The first is that, this is a truly an augmentation, right? So the system is not going to replace anybody or anybody's jobs, nor will AI tools for quite some time. This is meant to make your job easier, essentially, and also increase the efficiency and effectiveness of your outputs. From an implementation standpoint, that's one of our massive differentiators across this landscape of technology, is that, again, we truly built this to be a self-serve, no-code system. So our time to deployment is light years ahead of everyone else. We can show up on site, provision hardware, position cameras, capture training data, train a model, deploy the model, and then validate the efficiency of the model in about 3 to 5 days, which is unheard of. Typically, you would have to spend 3 to 6 weeks, oftentimes months, to deploy a single model. So, I mean, this is what we do. We've got it down to a literal science, no pun intended. And the resource footprint is so small compared to what people expect. We really, again, our whole goal is to make your jobs easier with the technology.
You actually, Jesse, you mentioned to me offline that a week ago or so, you did a Kaizen Copilot event. Mm-hmm. Would you be willing to share some of that experience?
Yeah. So essentially, we were at a customer's site that was looking to increase overall yield on the entire. They have an objective to increase overall yield on the entire floor by a certain percent in the next year, and our tool is one of the main levers that they are using to pull to reach that. And it just in the first day, in one of the lines, it was I think 9 stations, maybe 10 stations, and we identified I think it was 28% of the cycle time was waste that we could get rid of right off the bat. And it translated into, I think, a third. If we could get rid of that and rebalance the line, that translates into a third of their production goal right off the bat. And that was done in the first day. So imagine what they can find. And that was done on the first day on a single line. So imagine what they can expect to find and achieve by utilizing the Kaizen Copilot tool across all of their lines, right? And so that's really, that is kind of a shining example of what we expect to see from people when they utilize the Kaizen Copilot, is the ability to identify how they can get to their objectives a lot faster.
And from my point of view, Richard, from the standpoint of us, the quote unquote experts in mixed model line design, this sounds like, especially the Kaizen Copilot, sounds like the perfect complement to what we do, right? It comes into the roadmap to support us with time studies and then some, so we can do our proper resource calculations and then use the data gathered with the Kaizen Copilot for line balancing. So that again turbocharge us as resources for our clients. This and then leaving that knowledge with the client, which is always what we want to do, is to teach the folks that work with us to do this by themselves. Now with a tool that helps them do it, rather than now go and go to the floor and do the time studies all by yourself. I see a question there from Mike. Mike, when it comes to price and all that, I'm going to ask you to please contact Jesse directly. I'm sure he knows everything about pricing, I'm sure. All right.
And Michael Morris, you've got a question. Does this translate visual data into written best practice for process and or individual work in motion instructions? Or does it do augmented reality through operator headsets? So this is a equipment-free application. So essentially what we do is when we deploy the model online, the webcam, your PoE camera or your webcam is what's doing the observations. You have a screen at the station as well. The screen is providing the digital work instructions. And that comes from, in the initial phase of training the model, the first thing we have to do is annotate the steps in the cycle so we can marry the naming convention with the activities that are being performed. And so the operator will see digital work instructions on a screen, or we have the option to use a short throw laser projector and project the work instructions directly onto the work surface or the components itself.
Got it.
All right. So we have passed the hour, and we promised that we'd stay within the hour. So Jesse, let's make sure that we do have all your contact information here for the folks to gather and contact you directly. And my parting comment is, please tell Zeeshan thank you for doing something for manufacturing. Seriously, nobody has done anything for us.
Yeah.
For decades and decades. Everybody goes through healthcare, and everybody goes to all other industries, but manufacturing, we're always the guys walking around with tablets and stopwatches, and this completely changes the game as far as I'm concerned. I'm looking forward, and then again, zero concern from my standpoint in terms of that's going to take my job. No, that's going to take the bad parts of my job and and automate them. So from my standpoint, I'm excited to see it, and I'm excited to partner with you guys. One last question. There may be someone in the audience interested or curious about partnering with Retrocausal. Is that something you guys do? How would you go about it?
Yeah, so we do work. So we have a channel program where we work with channel partners, value-added resellers, systems integrators throughout the globe because we are a global deployment company. And then from a consultant standpoint, we do. So we work with consultant shops and individuals as well in a couple of different fashions. And if you guys have any questions on that, feel free to contact me. I put both my direct contact information in the chat, as well as if you just wanted to schedule a demo, there's a link in there too. But it's something that we do. We're always expanding our reach, trying to expand our reach and broaden the scope of who we can talk to and who we can work with, at least from a simple market education standpoint, right? So I have conversations with consultants, typically once or twice a week, that are looking to exactly what you said, streamline certain processes of the work that they do on a day-to-day basis. And, the Kaizen Copilot is really the perfect fit for that. So yeah, if you're a consultant on the call and you want to talk about that, feel free to reach out.
Okay, so I think we're reaching the end of the session.
Yes.
Last reminder that Mixed Model Line Design Workshop is coming up August 6th. So if you're interested in that, I think we have the link in this on the right side of your screen. I'm not sure what you all are able to see, but there's a link there to the information page. And that is a life-changing experience in itself. Will you testify to that?
As a previous student, I can attest that it is definitely worth it to get out there.
All right. Thank you. So with that, I think we'll let you all go. Last words, Gerard?
Again, all I can say, please tell Zeeshan, thank you for doing something for us in manufacturing space. This is as Michael Morris said, where have you been all my life? Well, my life has been too long, and you guys are too young, so that's the problem. Well, no, my life has not been too long. I want it to be longer, but it is just good use of available technology, and for that I'm nothing but thankful and looking forward to seeing this making the life of our people easier.
Definitely. I'll pass that along. And thank you guys for having me. It was a pleasure.
Thank you. Thank you, Jesse. Thank you all. And until next time, we'll be in touch.
Okay. Bye now.